So today I've got Jack Schroeder. He's the VP of Technical Services here at Igor, but he brings more than 20 years of IT experience to the Igor team with a background in network administration, technical support, operations, global engineering support, and has had multiple leadership roles in IT and operations at other companies as well. At Igor, he's responsible for all project implementation and post-installation support. And he manages a very quickly growing team of engineers and technicians who specialize in Igor's PoE technology and provide on-site installation services in addition to remote support. So that's a lot. He is a man who does almost everything that you can think of under the sun that we need done, but great person to know. And I'm very excited to introduce and turn it over to Jack. So Jack, please take it over.
Kim, thank you very much. Yes. Definitely lots to do, and I hope you find this presentation beneficial. As Kim had said, it's a introductory networking 101 for PoE technology, but really in an Igor style. So we're going to try to talk a little bit about networking basics. We're going to cover some terminology. We're going to review the components of our Igor platform from hardware to software. And then we're going to talk a little bit about network design, distributed versus central, the use cases, and then really wrap up with some final thoughts, and then hopefully have some Q&A. So overall, I'd like to start off with just describing what PoE is. If you've been on the other webinars, obviously it's a power over Ethernet. It's a technology that we use to control lights, sensors, wall controls, actuators, anything really that can be hooked up to line voltage. We are finding more and more technologies that can be hooked directly up and controlled through Ethernet. But it has been around for a very long time. You can think of it as analogous to VoIP phones. So the IP phone base, which has been around for 20 plus years, point of sale equipment. So it definitely is a tried and tested methodology and technology, and has been around for a number of years. And really what the benefits beyond just converging a couple of different teams, it really reduces the cables, the number of power supplies, the conduit that's run. So there are a lot of advantageous reasons to go with PoE for lighting controls and for other asset tracking pieces of technology for the actual building controls. So here is our technology stack. It is ever growing from the bottom to the top. So our cloud portal offering is something that continues to grow in robustness and is really taking off. A lot of customers are wanting that enterprise control for our technology, managing multiple sites, locations, buildings. If there's a need to split it up logically or physically that the gateway system can't do, portal access is definitely something to look at. Down to the actual gateway itself, it can be physical, virtual, but it is software, and it is the brains behind our entire platform. And then we'll be covering a little bit more closer or an in-depth look at the power sourcing equipment, the PSEs. We'll go through some terminology. I think of them as switches from my IT hat. And so it's really about bridging those two gaps and really understanding what the requirements and the terminology are. And then our Igor nodes. So we have a multitude of nodes that are out here. This one is our Rev 5 design, which is a very flexible design to be able to power a multitude of things as well. And what can it do? I mean, we've been talking about it a little bit, but LED fixtures, wall controls, sensors, motorized shades. You've got heartbeat monitors, bed sensors, meters, pressure, anything that you can think of, CO2. And then really the other cool thing that we have is the API, which allows for, again, many technologies to be integrated into our platform. One big one that we deal with almost on every single project is BACnet. So our BACnet stack being able to call and change and read a state of a space or create action based upon a request from the BMS system, the building management system, is definitely something that we do. So really, starting right up at the cloud to gateway integration or the connection really requires some type of physical connection. It requires networking. So, even throughout the entire platform, I mean, you're going to be looking, and we're going to talk about a little bit more the different layers that we go into. But then we move down to really the switches, and really from there, you're talking physical connections to the actual space or to the nodes that will then be wired into whatever device that we are controlling. And so we will be covering and looking at each one of these. And so it really begins with understanding from a network basic. I don't know how many people have seen this. Again, from an IT standpoint, this is the OSI model. It takes you through every single layer is touched, of course, for our technology stack. The application layer, the presentation layer, session, transport network, data link, and then physical layer. You can think of them as ever progressing, going down and coming back up for each click, for each request. A lot of times I talk about, different layers inside of this OSI model. Layer 2 and layer 3 are always something that comes up. So I want to make sure that we're defining each one of these. But first, really, it's about, so we talked a little bit about the edge, the cloud to, or gateway to cloud component, which is, it requires access to the internet. So what layer does that really go to? And so that's where the transport layer will come into play. It's normally a router or some smart firewall that will be doing the routing off the edge. It's full layer 3 capabilities. It's a complete WAN technology. Two of those. I don't want to go too far into the WAN technologies, but we'll hit on a couple of the different topologies for network and design. Really, the network layer, it talks a little bit about layer 3 switching. So I like to always say, layer 3, we can route to anywhere. And it does combine both a little bit of layer 3. Layer 3 is really about IP to IP, so an individual addressable object through an IP address. So if you put in, www.google.com, it has an IP address attached to it. And this is where, if it was internal to the building, we would be able to browse or route directly to that using the network layer or a layer 3 switch. The next layer that down in the stack is really layer 2, and this is a lot of what we'll deal with. There's a lot of technologies nowadays where the switches come with the ability to do layer 3 technology, routing, access lists. So it gets a little bit unclear as far as what we're doing, or is it a layer 2 switch? Is it a layer 3 switch? So we try to be very discreet in how we actually go through and handle each project themselves by trying to containerize, either through distributed or centralized network, what the switch's role is going to be. And we don't really want it to play too many roles, because then it gets a little complicated troubleshooting down the road. But layer 2, it really doesn't care about anything else except for MAC addresses. It doesn't know the IP addresses. And again, nowadays the switches can, but it doesn't really care about that. It's doing it strictly off of the MAC address. And then the physical layer, I don't want to pass that by at all. That is the physical cable connection between the switch and the node itself. And so you want to be able to ensure, test, certify that the cables are crimped if you're not using pre-terminated cables, that you're getting each one from a project standpoint terminated and certified that it is ready to go and it can handle whatever throughput is necessary. So keep that in the back of your mind. So really talking a lot about layer 2, layer 3, just covering this a little bit more. You'll hear VLANs, virtual local area networks. There are lots of ways to be able to segment a network from physical and logical access. And one way to do that is through a VLAN. But layer 3 is important because it can communicate outside of our network. This comes into play when you're bringing in integrations. If you've got a backnet system that needs to talk out, then how do we actually route communications to there? If we're going to go to the internet, how are we getting out there? So layer 3 switches and routers and firewalls play a heavy role in being able to not only route traffic, but protect it as well. And then of course, layer 2, it only talks about and cares about MAC addresses. It does have a single broadcast domain, and you can think of it as its own island. There are ways that you can, through topologies, really expand that horizon, but It's really about the, what it can communicate only within its own network, so to speak. So talking a little bit about networks. So there's again, I've already probably thrown out WAN already. There's WAN networks, there's LAN networks, there's MAN networks, there's HAN networks. So wide area networks, metropolitan area networks, local area networks. What do all these mean? It just means ways of defining topology of a network. So WANs will definitely have routing technology. You'll probably have dedicated circuits between you worldwide. So you can think of it as you have a data center in Singapore and one in Council Bluffs, and you want to connect those two. Well, how do you do that? Well, you're going to have a private WAN, some type of technology to be able to route traffic between there. MAN is a little bit closer. If you're looking at from a globe, then you're going down into really what does it look like from a city or county perspective. So you again have same technologies between the WAN and MAN, but the geographic distance, the cost, all those good things will hopefully be significantly less. And then local area networks are really defined by rooms, buildings, offices. It's really upon the IT teams to define what each one of those are. And then over to the right, there is a little bit of technology just showing, how do we actually connect all of the different things from iPads to, switches to notebooks to PCs to printers, all that good stuff. You can think of this as sort of a LAN going to a WAN type of network. And then we've got some IP addresses, and what do those IP addresses actually do for us? And these are all private class IP addresses, 192.168.0.1. I will bet money that each one of you has either set up a network at your house or had one installed that has a 192.168 address. And if people get really technical savvy, they'll change it to a 172.16 or a 10.0 network to make it a little bit more robust for handling a multitude of devices. And IP addresses are going to become very important as we go further on into this conversation. You look at the total number of IP addresses provided by each one of those class of networks, and you got to think about it as a large, or if you're a small business, obviously the 192.168 address will be fine. But as you get larger and larger, the number of IP addresses definitely, and devices that you can have on your network gets constrained before you get too far out. So why is this information critical? It's critical because the number of nodes and the number of switches on the network will determine the number of IP addresses needed to create said network. And we'll get to how we actually determine some of these things and when does it need to come into play from the actual network itself. Here is an eye chart. I threw this in here very purposefully because it does talk about a lot of different things. So IP addresses and subnets are very important, and they provide a list of available addresses to be able to prescribe a node to. Going back to my original slide, and we'll talk a little bit more about this, but the nodes are the ones that have the IP addresses. So every device that is hooked up to it is controlled through software. They have a unique MAC address. They're given a unique IP address. And so those are the ones that we'll have to be very concerned or at least concentrated on as we define our networks themselves. So, from the 192.168, the Class A, Class B, Class C networks, you definitely see over on the upper right-hand corner the subnets that are associated with them. And again, this gets very down into the weeds very quickly from in here, but you can see the total number of available addresses. So over on the left-hand column, the address availability as you get further and further down the stack really will play a big piece in defining what type of network or what conversations need to happen with the IT teams from that standpoint. So what IP address can I use? That's the big question that we need to understand. It's sometimes already handed to you. There's already carved out subnets for lighting networks themselves. So is it something that is from the 10.0.0.0 address? Is it a 192.168 address? What is it that we're trying to do from that standpoint? And what IP addresses can be used? And it's really a conversation between the actual IT teams. If it's not an IT team, then really it's about what building, we'll come in and propose one solution. It's never set in stone. Everything about this technology is programmable, so IP addressing is something else. So then you get into how do we actually assign addresses. So Dynamic Host Configuration Protocol, DHCP, is the technology that we use, and it's great from a number of different things. So DHCP allows us to be able to leverage not a manual process to, I guess, assign IP addresses. So it reduces the number of touches that we have to have onto a node. It allows for the flexibility. So as I said, if we come in and we've defined one IP address range, and all of a sudden we need to do another, it's a couple of clicks, and then just a little bit of time to actually change the IP addressing of the entire network to fit into whatever prescribed subnet or IP range that we need to play in. There's a lot of different ways that we can assign or host DHCP so that our nodes come online. And really, so it goes, we'll get into this a little bit later on in some diagrams, but when the node comes online, it'll look for and be told where to get an IP address from. So, where can it live? It can live on a router, it can live on a switch, it can live on a PC, and there's lots of different ways to go about it. And each project, we've done different things, different modeling to be able to understand what is the best way to do it. So in some situations, a router coming from the outside is not necessarily allowed into the project. So therefore, we would look at hosting it on the switch stack, the aggregation switch, the core switch, or we'd be looking at hosting it on the actual server. So then you got to look at, okay, what happens if power is cut out? And so really understanding all the complexities of the actual solution to be able to say this is the way or this is where it needs to sit to be able to have the most available DHCP server, because it is very critical to be able to do so. Again, this doesn't it doesn't preclude the client bringing their own DHCP server, but we just want to make sure that whatever range that we're being carved out from that standpoint, that really it's for Igor nodes. Not to say that we can't play in larger subnets and have multiple IoT devices on there, but definitely it helps with identifying if there are issues inside of the logs. From broadcast messages to other things, really helps us to be able to identify what may be going on from a switch or network standpoint. And you can't have too many cooks in the kitchen. It's very important that you only have really one DHCP server assigning. There's definite ways to be fault tolerant from a DHCP standpoint, but having multiple DHCP servers definitely can complicate the troubleshooting. And does sometimes, it can cause issues inside of networks. So being able to understand that if you've got a geographically dispersed topology, how do you actually localize the DHCP service for that from that standpoint? So here is a PoE glossary. So again, when I first came on board here a little less than a year ago, I was, coming from an IT hat, so a lot of these different words and technologies were somewhat similar and others were not. So PSE, power sourcing equipment, that really can be a combination of different things. Inside of the diagram that I have to the right, it really is about a UPOE switch sitting inside of a IDF or data closet themselves. So to me, PSE is equal to a switch. From that standpoint. So PD, power device, so that again can be anything that PoE touches that is being powered by PoE power. So IP phones, wireless access points, security cameras, Igor nodes, and so on. And then really getting into an N-span versus mid-span. So an N-span itself is really more typical of a switch, again, with PoE capabilities. And again, that goes back to a PSE. So you see how all of these different things tie in together from that standpoint. Midspan is a little bit different, and we'll go into a couple of them, and we'll talk a little bit about the network topologies for what a midspan would look like versus what an end span or a switch would look like solely. But a midspan is an interesting component because it allows for power without having data. So it's an added switch. It's an added U into a rack. It is a technology that just will inject power onto data lines. So if you have already switches involved and you wanted to quickly get, instead of procuring a new switch, you could look at adding in a midspan to be able to leverage from a POC or something like that, to be able to really understand what the Igor nodes or technology is capable of. And then we get into MDF and IDFs. You see the different terminologies for each one. Realistically, an MDF is sort of the main hub for all technology. I would really consider that more of a data room, not a data closet. It aggregates a lot of different floors. So if you think about a building, you've got a lot of IDFs on a multitude of floors, with one floor sort of dedicated as the MDF, or an aggregation point for all of those. It would have a lot more technology than just Igor switch technology. It would be where the server would potentially be housed, or the virtual server. It would be where the DHCP server would be. So again, it's a larger room than an IDF. An IDF can be very small. As long as it has ventilation, switch technology nowadays is very stable from being able to operate in hotter environments. So it really allows for, to be a very small space. Not too small, but definitely, a couple U's. But it goes into the overall thinking of how do you actually design a network as well. Again, I want to make sure that everybody understands PoE standards. So something that you can look at here, and a couple things that I'll focus in on is UPOE, which is a 60-watt design. So there's a lot of different technologies out there from a 60-watt. Cisco specifically has a lot of 60-watt design. But then 802.3 BT standard came out and is a 90-watt design, and that allows for a lot more robust solution to be able to handle, again, class 2 devices. So again, it doesn't require electrical conduit. So that's, again, the advantageous nature of our technology, is being able to free fly cable through the ceiling, but definitely allows for a lot of power to be pushed out to whatever we need to power from a device standpoint. So IEEE is the standard that publishes a lot of the, obviously, PoE technologies. Cat 5e and Cat 6 cable are always recommended. Depending upon the length of run, all those different things, you will want to work closely with your IT teams, the Igor teams, to be able to determine what would be best. So again, 4-pair, twisted 4 pairs basically gives us the ability to have the power out, to really provide that delivery to the fixture, to the wall controls, whatever we may be powering at that time. And so now we're going to focus a little bit more on the actual power sourcing equipment, or as I would say, the switch stacks. So again, we talked just quickly about and defined the technologies between midspans and switches or end spans. But definitely want to make sure that we spend a little time on, different setups, from a stackable to a centralized solution to what does it look like to actually plug in a midspan. Igor has done a lot of testing from our hardware standpoint to be able to certify switch technology. And there's, again, a multitude of PoE switches out there. I mean, from you have Netgear, you've got Cisco Meraki, you've got Ruckus, you've got Transition, Versatech, Cisco, Dell. All of those are definite ways to be able to power a PoE PD device, a powered device. So what we try to do is we work with the manufacturers, and we try to establish approved power sourcing equipment. And that can be found up on our support website as well. So it's definitely, if you haven't been there before, support at igor-tech.com. sign in, create an account, and you can get access to a lot of good technology and documentation. So here we'll look a little at some Cisco technology. UPOE Plus, again, I'm focused in on the 90-watt design and delivery, I think, because it offers a lot more bang for your buck. You talk about cost per port, so a 90 versus a 60 watts, you're able to power more fixtures, still individually addressable fixtures. So again, it still allows for each individual light, if it's required, to be able to control individually, but it gives a lot more flexibility to be able to power more devices out there. So you're looking at the Enterprise Class 9400 series here. And again, there are different ways to pick up and prescribe each one of these. And depending upon, if you're doing a small building, if you're doing a floor, if you're doing a couple of rooms, or if you're doing a full-blown floor of a large open office area, which is going to be right for you. And again, there's going to be conversations about best use case for distributed versus centralized switching, but definitely these are some workhorses for Cisco. A couple of cool things about these, as you have to upgrade firmware, if you have an iOS version, you see the dual chassis from a supervisor card standpoint. That's very important. So when you schedule switch maintenance, it's always important to be able to have a failover mechanism, and Cisco's technology here allows for that failure to be only on the supervisor card that is impacting. So again, it won't impact the technology, the heartbeats that go out to the network. It really doesn't lose a beat when you're able or need to upgrade the iOS version. So definitely some cool technology here. So again, this is I would consider it a layer 2 or layer 3 switch. This is mainly used for centralized network designs. And this switch stacks can definitely provide DHCP service as well as a multitude of other different things. But those are really the main focuses for Networking 101. Here's a little bit different take on the, I would call these like pancake or stackable switches. It allows for greater flexibility. So if you need to have only 24 ports, you don't have to go with the 9400 big chassis taking up 7U. You can get a single U switch to be able to provide the necessary ports required to power the fixtures there. So it definitely allows for a lot of flexibility from that standpoint. It comes in a couple of different flavors. It used to be a 3850. Cisco has now come out with a 9300 series. That's been out in the 60-watt design for a number of years. And now they're getting out to the 90-watt design for the UPOE++ models. Some interesting things that, we work very closely with a number of manufacturers, and the power that that Cisco is providing to the 9300s is going to be able to be advantageous for the designs when you talk about number of ports being able to be leveraged. Going back quickly, you can leverage every single one of these ports on the 9400s for PoE power. We'll get into some switches where that may not be the case, and it's really due to the way that the power supply was designed from that standpoint. But with the 9300 UPOE++ models, the actual power supplies are going to be able to power all 24 ports, and I believe almost all 48 ports too. I'll have to go back and look at my notes. But it is stackable technology, so it allows for greater flexibility. It can be used for DHCP and is utilized for centralized and distributed network designs. So it definitely, again, has that robustness that we're looking for as well. This is a cool technology as well. I don't know many other plenum-rated switches that are out on the market. And so I always like to look at this one a little bit closer. It is a 60-watt design, but it allows for and is created for that distributed network design. And it is cool technology to be able to see up in the ceiling. There's some making sure from a maintenance standpoint that you've got it all buttoned down, being able to have as-builts to be able to detail out exactly where they are. So access to them if there's ever a need to swap one out, or troubleshoot it at the physical layer is always the interesting game that is played there. Transition switches, so this one is definitely a workhorse for us as well. It is 24 ports of PoE power at 90 watts, but if you quickly do the math on the actual power supply, you'll see that there is a limitation, and this is back to my earlier comment, where we run into some issues. And it will, I mean, the cost per port, the number of ports will play into the design, will play into the heating and cooling for the closet, for the MDF. It will, talk about rack storage. All these different things will play into, the total number of cables, where the cables are run to. So it plays into cost is really what it comes into. So working with Igor, working with your IT teams, making sure that you design it optimally from that standpoint is always key. And as I talked a little bit about earlier, there was conversations about Microsemi, well, not Microsemi, but really midspans in general. Midspans themselves are cool in the fact that you can just put them, you got a switch, you're ready to go, just go buy a 1-porter, 8-porter. There's a lot of ways. I mean, literally, if you have a router at home, you could buy a PoE injector, use one of your ports off your router, make sure that the DHCP server was there, and you could start having PoE power. So it's really simple to do. You would, of course, have to have Igor technology to be able to control that. But it's very quick and easy to be able to do stuff like that. And so midspans are a quick, low-cost model to be able to get where you need to go. And they definitely have the flexibility that we're looking for from a 90-watt standpoint. They deliver a lot of power. As you can see, the PD 9600 series offers a multitude of different power setups. They actually have a 24-port version as well. So there's lots and lots of different things that are coming out from the midspans. And here's the example that I wanted to really quickly talk about. So you can see that there's a little bit different cabling that we'd have to think about. And you can think about this, the highlighted or a little outline box on the right-hand side. Example 1 and example 2 are really about what is in the rack. So in the rack, you are mounting an N-span or a Cisco switch, and you have 1U or 7U or whatever Cisco switch you're using. And you're able then to directly cable that into where you need to is in a patch panel, and then you patch it down into the Igor node itself. Or you're going to be looking at a midspan solution, which requires that network or data only switch that you already have or you found, and then you inject power through the midspan itself. So again, you're making connection inside of the rack between the network switch and the midspan, and then you're pushing out the connection to the actual PD or Igor node. So it definitely is interesting from how they're racked and how they're cabled. You have to buy a little bit more cable for one versus the other. But there are definitely benefits from cost, and how you're going about and what's the size of the project. So again, there's lots of different things to be able to think about before you make the design step to which one you want to go with. So really now we're going to focus a little bit on the nodes. So we've, of course, now you can imagine we've got our cloud connection to our gateway through some router technology. Maybe a firewall's locking it down so it's discreetly talking on specific ports. You've got the gateway in-house on a virtual or a physical server. You've got connections coming out of that server into the switch via aggregation switch, patch panels, whatever it may be. And then from there, you have an RJ45 Cat6 cable or Cat5e cable running into a patch panel. And then from that patch panel, it runs into a node, and that node is powered. So, what can it do? This is really cool. We talk about this, and I think every single webinar has talked a little bit about this, is our daisy chaining technology. And why is this important? Because not only does it allow for you to then cut down on the total number of home runs, look at the number of devices you can have on there. Now, if you have a whole bunch of light fixtures that are at 25 watts a piece, you may only get 3. But if you have a whole bunch of different things that you want to power, from switches to shades to sensors and relays and lights, I mean, you can go 5 nodes on a daisy chain that equals plus 32 devices on one home run, all individually addressable. So again, you have discrete control of those pieces of technology, from a fixture to a sensor, to be able to really allow the full control of Igor's platform to help with that. So it definitely is cool from that standpoint. Igor Nodes, again, you're looking quickly at this, multiple fixtures. You have Igor bus limits. So we're talking, how many different in a chain can we actually power? What we are finding, and again, I think this is probably true to a lot of projects that we have, it's really the PSE that limits us on the total number of devices that we can have. We would love to power, 32 fixtures out there on a daisy chain node. I'm gonna make it a goal one day to actually work with David and design that, so that we can actually, our lead designer, he did one of the last webinars, and really figure out exactly how we will go about getting 32 different fixtures on one to power it. So it's really going to be an interesting play as LEDs get more and more, I guess, better energy use. The power consumption for the actual fixtures will continue to go down, and so there's lots and lots of ways that we'll hopefully get there. But being able to power 32 fixtures, I think, is key, as well as 32 devices, the way that I would look at that. And again, it requires I don't want to spend too much time on nodes, so I don't have too many slides on this. But we have network nodes, which are connections directly back to the power source equipment, the switch. And then we've got device nodes, which are outlined here in blue and blue. And really, if you picked up a node, you thing. Yellow, you plug into the PoE switch, and blue, you would plug into another node down the daisy chain. And so, some of the great things about our technology, and really it's about protocols. So network communication, DHCP, TCP, IP, UDP, CoAP protocol, all of those. You can see on here is a legend for our different ways that we talk to various technologies. So a couple things on here. HTTPS, so 443, 80, 80, 81, are really how you would communicate up to the cloud or to the actual gateway itself. We've got technology to be able to remotely upgrade our firmware on our nodes. So you'll see a little bit on there for firmware updating. You've got different emergency services, you've got sampling services, and you've got CoAP really doing its job from a connection and communication standpoint. So it's low bandwidth. The good thing about it is that we have low bandwidth requirements, but we have plenty of capacity. So I think that's key for being able to integrate with others out there, is that we have plenty of, our nodes have plenty of capacity to be able to share data streams, to be able to ensure that we're passing and integrating with the right players, and being able to send data, near real time, if not real time. And finally, I'd be remiss if we didn't quickly hit on the, the devices that we're connecting to our nodes. Just highlighting a couple of these right here, and really providing just, a quick slide on the different devices that are out there. Again, you can see on here that you've got a whole bunch of different daisy chain nodes on here. Depending upon the technology that's used in this slide here, it is Rev 5 nodes, but you can imagine what it would look like from a 90-watt design. But you can see the flexibility that we have here. We've got motion sensors, we've got can lights, we've got and these are probably in multiple rooms, if not in a very large open space, being able to control it. And then you see wall controls connected in there. So our connections directly to fixtures, 18.2 whips or custom whips coming off of the fixtures directly to our drivers. 18.3, 18.4, 22.6, really 4 different switch technologies that are out there. But what we're really focused in on from a physical layer standpoint is making it easy for our clients to be able to just hang a fixture and power it by plugging in a RJ45, a actual CAT cable right into a fixture. So integrations directly into or integral nodes into fixtures is also very important as well. So definitely work with OEM manufacturers, different conversation and different probably webinar from that standpoint. But it is about ease of use and ease of installation. And so we try to go to great lengths to do both of those from that standpoint. So we'll talk a little bit about distributed networks. Here's a very high level diagram of a distributed network. And where do you see these at? From just past projects, very large open spaces like warehouses, school systems, even hotels that really want to have like their own, there's so many different ways that you can set up a distributed network where it has a very discrete, VLAN or subnet on that actual switch to be able to provide IoT access to a multitude of different things. So we work closely with other IT teams, thinking about their visions and really understanding what we're trying to achieve. Here's some CDB8Us, plenum rated, that are ceiling mounted. It definitely requires less cabling. So to get to the actual luminaire or to get to our node that is controlling the fixture / luminaire is really about, you're talking 50, 20, 30 feet versus, 100 meters or 50 meters. And then you think about the number of cables that may have to run back to a centralized network. So the distance limitations, there's less of those. So there are going to be more switches, especially depending upon how many different devices you're trying to connect. So there's always this weighing, and we've developed some good algorithms to be able to help push customers or really help educate customers on where we think they need to go. But again, this is not made in a vacuum from our standpoint. We want to make sure that we take into consideration if you guys are working with a specific vendor, if you are a transition or Cisco switch shop, what is the best way for that? If you've already got established IDFs, if this is not new construction, but we have access to the ceilings, all of these things come into play here. So the big thing that I do want to highlight is, the difficulty, and it's really to a degree, how often do actual switches fail? Not often. But you do have to understand exactly where they're placed. So if you have them in very busy areas, so taking a warehouse, you're having to climb up on a very high ladder to be able to service them. Those are definite things that you have to consider when deciding to go with a centralized or a distributed network. Couple things about topologies. So network topologies, we talked about the larger network topologies, but now we want to really just hit on a couple of different things. So daisy chain, ring, and star topologies. You can think about daisy chaining switches together, just as we showed with our Igor nodes, which is connecting one to the other to the other. That is a way to be able to get a lot of nodes online without having to really pre-configure the switches themselves. But if you think about it, if something in the chain actually goes down due to power outage in a very specific area, you're going to be taking down the other technology or other switches and other lights down the road. So you have to think about how best to leverage that. Ring topology is exactly what it thinks about. You hook up the switches into a ring so that, again, if one side of the link is broken, the ring still communicates. So you think about power, you think about data, you think about aggregation switches, and then really star topology. So again, you have an aggregation switch that is sort of the home run for all distributed network switches out there. And there are hybrids out there from that standpoint as well. Centralized networks, I see a lot. And again, it's about 60-40 from, and again, I think everything is always ever evolving. And it's really a combination of conversations that are had. But centralized networks are definitely out there. But if you think about a centralized network, it's really a distributed centralized network. So it's a hybrid of the two that we just talked about, because again, you'll have a localized IDF on each floor, and then you'll have one centralized data center that you'll want to terminate all the core technology to be able to really have the most efficiencies from that standpoint. That's not to say that you can't have a floor by floor, just isolated network. You certainly can, but I haven't really seen too many of those from that standpoint. So it uses existing power infrastructure. So again, it would use your own IDF closets. You have the ability to carve up the network from a logical and physical standpoint. It does centralize the activity of the equipment. And it definitely allows for ease of use or ease of maintenance to be able to perform on there. Again, the same technologies apply from the overarching topologies, so you can have it in a multitude of different ways from that standpoint. And then really it brings me to our takeaways. So, some things, bringing my IT hat to the table, I would say always involve your IT teams into the process early. Weigh centralized versus distributed network designs. There's a number of things to think about, and that's where Igor can really shine and help you understand a lot of what is the best way to go. The number of nodes, the switches, how do you want to design the network? If you want to segment off all the switches from the server and you want to have the nodes on its own VLAN, there are lots of ways to be able to carve up networks. And then really the last one is to leverage our daisy chaining technology. I think it is an incredibly powerful technology to be able to leverage, and definitely helps reduce the number of home runs that are out there. And finally, I definitely always like to leave some useful links. So again, having I hope this presentation will be shared so that you guys can click on these links. If you're just getting into understanding, how to design PoE networks or when to involve IT, this will give you some great overview as to how to leverage the available information and then when to actually have the conversations. And I thank you guys very much for your time today. Kim.
Yes, excellent. So thank you so much, Jack. We do have questions. As a reminder, we will be sharing this presentation as a PDF in the follow-up email. So
Awesome.
you will get that in the links. Let's just start with some questions about Cisco certification. Sean,
yes.
Is there any Cisco certification required to design and install Igor services? And Jim is asking a kind of a similar but reverse question. Does Igor require Cisco certification in the Igor process?
I think that's a great question. I think either way that you ask it, it definitely has value. If you have the Cisco certification, and switching and networking, I think is the one that I would go after to really help. It is not required to be able to design an Igor network, but it allows for definitely a deeper conversation with us. If you have that background and understanding as you go through the design process, it definitely is beneficial. Something that wasn't asked, but from a certification standpoint for design, we are always and ever evolving. I know we have Igor universities now, and that's something that we definitely have on our roadmap, is to really get Igor certified design certificates and training classes. And switching is going to be definitely a part of that. How and best when to prescribe what switches. We're going to dive into that in great detail. But I think having the background from Cisco is beneficial. Really, any IT certifications around switching and networking, I think, are definitely a plus or a checkbox on the positive for having an advantage over, say, somebody who does not.
Thank you. Carl is wondering, does the Igor Cloud Gateway software provide a data visualization tool?
We do have data visualization. There are right now some screens for energy consumptions. We have, what is the most used rooms, all the different things from that. So you can slice and dice your data from the cloud from that standpoint. We are always working on more visualization from a dashboard, how best to slice and dice it. We've got clients that will just push it into Power BI and slice it up from that standpoint too. So the data is readily available and definitely ever growing. So slicing it up, visualizing it is key for our success going forward too.
All right, Sean has a multi-part question, so I'm going to ask him sort of separately here.
Okay.
If you know, can Ubiquity products be utilized or recommended?
Ubiquity products, right now we haven't certified them. We are actually working on to get some into our office. I know they have a robust platform, and truthfully, I believe we've even had one or two trade shows where somebody didn't have anything else out there but a Ubiquity solution. So we have used them, but they're not an approved PoE solution for Igor technology yet. And I always like to caveat that, because again, we will try a lot of things, but once we get it into our possession, Andrew Pospisil, the director of hardware engineering, and the team behind him put it through the paces to make sure that that's everything that we need to do, from heat to multi-daisy chain units to all those different things. So at this point, Ubiquity is not one, but I would be looking for some updates in the very near future.
All right, and then the rest of his question is about cybersecurity. So what about protection from cyber attacks? Who is responsible for implementing that security? Is it Igor or the client?
Security was one of the founding thoughts behind the technology platform. But I would say that it is both. I would say, we come to the table ready and armed with multiple different ways of being able to, from API tokens. I didn't really get into the software side too much, but we have token-based security systems. We've got discrete ports that we talk on, but it really requires, the client to be also very forward-thinking from a security standpoint to really secure it. Usually the PoE network is further down or segmented off of the other IT networks, but it's still always a vector or avenue for attack. So again, I think we probably need to have like a security 101 so we can talk a lot about that. But yes, I would say it's, we come to the table ready and willing and able to implement a multitude of different technologies, as well as just right out of the box. But then it's also a conversation with the client to really, we want to make sure that we are fitting the client's IT model. We don't want to ask for an exception to their IT security policies. And so that is something we're always striving to do. And, to my knowledge, we have very much succeeded at.
Okay. James is wondering, for long runs, do midspans retime to give you another 100 meters?
So if you're wanting to basically inject the power at another location, I've actually never done that. I don't think so. I think you'd have to think about both data and power. So you'd have to, again, have the data with the power at that long end of the home run. But if you were to say have a home run from the access switch to the midspan slash PoE switch, or just really the data only switch, and then have another 100 meters, theoretically that would work. I guess I've never done that to date, but theoretically, just looking at impedance and power loss, I think that it would potentially work.
Great.
But again, we want to talk to you at that point.
Yeah. All right. Jeremy is wondering, do Focal Point's newly announced PoE fixtures work with Igor?
I don't know if I'm announcing anything, but I believe they all do from a Focal Point standpoint. Maybe you can.
It might be an Andrew question.
Yeah,
right.
That may be an Andrew question. I don't want to say, I think they're an ecosystem partner though too. So we'll take that one back.
Mark is wondering, how many total ports can you run at 90 watts on a 9410 switch?
it depends upon the number of cards that you have on there. But you can run pretty much, I mean, each power supply on there is 3,800 watts. So if you take 3,800 times the total number of power supplies, 8, and then you divide that out, I believe you can run all ports off of that at 90 watts. And I'm sorry, I'm going to have to do math in order to get that done. I don't have that with me right off the top of my head. So let's quickly do that.
All right, so Chad is wondering, he's commenting, from what he can see, Cisco Meraki is not a supported PSC platform, but the Cisco Catalyst is. When will Meraki be approved to use?
That is on our roadmap as well. So I would say in the near future, you would be looking for that to be an approved list as well. Again, we try to, it's not an instantaneous, like, hey, we've got the device. We have a set of tests that we like to run. I know that we have Meraki's in-house, and we're looking at them right now. So I would say soon it's on the roadmap.
All right, James has submitted a couple of questions. I'm gonna pick one here. Can your experience help grade different topology investments we could make to link levels of investment to levels of single failure risk? The more money, less risk?
Yeah, I think that, you know, you get what you pay for, I think is the first thing. So there are, you know, from a network design standpoint, you really put on, you know, different hats to be able to protect, you know, so going really deep, you know, you have different power coming into the buildings from different power stations being supplied out. That would be the best of all worlds, to be able to limit if you have one power station go down, the other one still is picked up, and we have enough power to distribute across the networks to the PDUs actually in the racks themselves, and then how you patch those or salt and pepper the actual power connections for the switches into those. And then you talk about cross connections so that you don't ever have more than 1 to 2 actual nodes for a room or for a space on an actual link, or you know, if you have multiple cards inside of a Cisco switch, there's lots of different ways. So again, you have to think about it holistically. It definitely starts at the design, and that's why bringing in IT teams involving Igor would really maximize you know, the bang for the buck from that standpoint. So yes.
All right, we're going to do one more from James, and then I might be able to fit one more from Sergio. And James is wondering if you could guess, based on all of our current installations, what is the % breakdown between PSD midspan, plenum PSD endspan, and powered by, in the rack-based PSD endspan in an XDF?
I would say, I don't have a percentage, but I can give a little history. So first, I want to say that, you know, a couple of years ago, we were talking about different switch technologies and different IEEE standards. So you're looking at more, you know, the 60 watt, 30 watt design. So midspan power was coming up. So I'd say the last couple of years, midspans were definitely a way to go. It depends upon the clients. The larger the clients, the more centralized, the more traditional the IT is. And so I would say from an overarching, you would have probably the largest is in centralized with a PSC as being the sort of driving force. But the number of projects would probably be, you know, midspans, and then the plenum rated would probably be the least number out there. And it's just because of the way that the buildings are designed more than anything else.
Then final question, just your quick thoughts. Sergio's wondering, what is your opinion about 5G? Do you think it could compete with the PoE market?
5G, I think, will have a role to play. I don't know how it would power the devices, but I think 5G definitely from a wireless technology has a lot of room to grow and being able to control devices out there. So I think it's going to be something that, from technology, it's ever changing, and Igor stays on its toes. So we are evaluating a multitude of technologies, 5G being one of them. So I definitely think it'll have a role to play. As to what, I can't quite say.
Great. Well, I think that's going to be it today. Thank you so much, Jack. Thank you to everybody who joined us. You all will get an email from me with some of this afterwards. Be sure to tune in 2 weeks. We will be really diving into our product, our new product launch, which is the intelligent disinfection for smart buildings. Certainly relevant with COVID, but applicable in a lot of other situations as well. So be sure to check out our events calendar if you want to sign up before we send this email. Otherwise, in the next couple of days, we'll be sending you a follow-up with this presentation, link to the presentation, kind of like all of the last ones as well. So again, thank you so much. Follow us on social media if you haven't already. And thank you, Jack, for taking time out of your day to share this presentation and answer all the questions.
Well, thank you guys, and stay safe and healthy. Thank you guys. Talk to you later. Bye.